Welcome everyone, my name is Mr. McGregor and this is the second video looking at speed time graphs. In this video we're simply going to focus on how to calculate the distance travelled from the area under a speed time graph. So here's a speed time graph and we're going to try and find the speeds of section A, B and C. To help us do this we're going to use our distance equation and two equations from maths for the area of a rectangle and the area of a triangle. So to calculate the distance, we need to find the area underneath the line. To explain why that is, I'm going to look at section B, which is the most straightforward. The area underneath the line is this green rectangle. The base of that rectangle goes from 10 to 20 seconds, and the height of that rectangle goes from 0 to 22 meters per second. So if I calculate the base, which is 10 seconds, times by the height, which is 22 meters per second, I'm actually doing this equation over here. I'm going 10 seconds multiplied by the speed of 22, which will give me a distance. So this is a little bit of a cheat really, to think about it as being the area underneath that graph, but it's very useful when it comes to calculate areas with triangles. So let's do that for section A. Section A is obviously a triangle, so I'm going to use my triangle equation, which says it's a half multiplied by the base, which was 10 seconds, multiplied by the height, which is 22 meters per second. And when I do that, I get a distance of 110 meters for section A. Section B is a rectangle, so I'm going to use my rectangle formula, base times height. In this case, 10 seconds along the base. Note I'm not using 20 here, because the base is from 10 to 20, therefore it's 10 along the base. And my height is 22 meters per second. Multiply those together, 220 meters. For part C, I have to calculate the area underneath it, but it's between the line and the axes. So in actual fact, I'm looking for this yellow area and the blue area. So between the line and the axes, we can see it forms a triangle there. Between the line and the axis forms a triangle here. And when I do the maths, that comes out as 220 meters as well. Often you're asked to find the total distance, so after you've worked out the parts, you simply add it all together, in this case 550 meters. Now I'm going to set you a bit of a challenge. Can you calculate the total distance travelled as shown on this graph? I'll give you a couple of clues. There's more than one way of answering this question, but if I look at it, I can see I have a triangle here, and I could calculate that area. I have a rectangle here, I have a rectangle here, triangle up the top here, another triangle, and this part here could be considered as a rectangle and a little triangle on the end. Or if you're smart, you might note there's one triangle here, there's a big rectangle here, a little triangle here, and a big triangle down here. It doesn't actually matter how you split this question up, so long as you break it down into rectangles and triangles, calculate the area of each one, and then add them all together, you should get the correct answer. And I look forward to seeing what you get tomorrow in class. So now you can calculate the distance travelled by using triangles and rectangles to find the area underneath a speed time graph. Thank you for watching.